How's this machine coming along?
Coming along very nicely. We're in the process.
S.V. Sreenivasan is on a constant quest to push technology to its limits. His hope is that the machines and processes he designed for molecular imprints in Austin will quench consumers' thirst for gadgets and computers that can do more, do it faster, and take up less space.
So the pitch of the discrete track here is what roughly?
SV's machines print nano-resolution features onto computer hard disks and semiconductor wafers that are the brains of today's electronic devices. Features that are 2,000 times thinner than a human hair.
You can make very high-density storage devices, which helps people manage their data.
One of the machines SV's team developed works by imprinting nanoscale ridges on the surface of computer disk drives. The ridges separate magnetic bits of data on the disks so their magnetic fields won't interfere with one another. The manufacturing process involves capturing a photosensitive liquid inside a mold and hardening it with ultraviolet light. The result is a precise pattern of ridges, neatly separating the sensitive magnetic bits.
We are able to basically pattern matter at the nanoscale, materials at the nanoscale, at a very reasonable cost, much lower cost than anybody's ever done before.
SV's breakthroughs came from a collaboration that began in 1996 with Dr. Grant Wilson, a chemist at the University of Texas. Wilson had developed an imprinting process that used photosensitive materials. He just couldn't figure out how to remove the mold without damaging the extraordinarily fine features.
You need to remove the mold without rotating it on the vertical axis or translating it in the plane of the image, even a few nanometers, or you'll smear off the image.
For help, Dr. Wilson turned to SV, then a new mechanical engineering professor at UT, who specialized in building precision machinery. SV's team quickly built a machine that could reliably remove the mold from the substrate without damaging the fine features. SV's team didn't stop there. They developed other innovations that made the concept viable.
We developed this ink jetting technique, a very precise picoliter volume ink jetting technique, where we can put down the liquid as a function of what is on the device, which is the mold.
The machine worked so well that SV founded Molecular Imprints in 2001 to bring his technology to market. SV's company could someday produce nanoparticles that fight diseases, or LED lighting that's more powerful and energy efficient.
We're now in the phase of figuring out how to get into volume manufacturing and really ramp up, because that's when you can say you've had societal impact, when people are buying stuff that requires your process. So we're pretty close to that, and it's very exciting.